Welcome back to another video by Codeshala. Today, in section 2, lecture 2, we'll be getting familiar with ways to check for error. So, when you transmit your data, there's always a risk of data errors. Data errors can happen in both long and short distance transmission. So, to know if there has been an incorrect transmission or an error while a transmission has occurred, we use error checking methods. Following are the error checking methods which we use. First, parity check. Second, ARQ or automatic repeat request. Third, checksum. Fourth, echo check. So let's start with parity check. Firstly, the sender and the receiver together decide whether to use even or odd parity. Next, a parity bit is added to the original data. Now, as you all may know, data transmission occurs using binary language. So parity bit is either a 1 or a 0. The receiver then counts the number of ones in the byte and then decides if the parity is even or odd. And if the parity type is incorrect, then an error is detected. But there are situations where parity check won't be able to find the error. For example, if two bits interchange, this won't change the parity value. Secondly, if the data produces multiple errors in the same byte, the parity value will still stay the same. Checking method is known as automatic repeat request. This is an error checking method which uses acknowledgement and timeout. Acknowledgement is a message sent by the receiver that the data has been received correctly. There are two types of acknowledgement. Firstly, negative, which means the data has been incorrectly transmitted, and secondly, positive, which means the data has been correctly transmitted. Timeout is the time allowed to elapse before an acknowledgement is supposed to be received by the sender. If an acknowledgement is not sent before the timeout, the sender then automatically resends the data back. Note, the receiver uses either parity check or checksum or echo check to check if the data is correctly transmitted or not, and then decides whether to use positive or negative acknowledgement. An example of ARQ can be your one-time password, which is generated every time you try to log in to your bank account. So our next error checking method is known as checksum. In checksum, a unique bit value is calculated from the data using an algorithm. It is transmitted with the data, and the value is recalculated after transmission using the same algorithm. Both the values are compared after the transmission to check for any errors. So our last error checking method is known as echo check. So in echo check, when the receiver receives the data, it sends it back to the sender. The sender then compares the two sets of data he has to check if any errors have occurred during the transmission process. Now, with this, we have reached the end of error checking methods, section 2, lecture 2. Thank you for watching.